Classwork 8.2 with your boy Springer. We're doing Introduction to Factoring Quadratics today. So, since mathematics is often described as the study of patterns, it's not surprising that generic rectangles have many patterns. Today, we're going to examine two of those patterns. So, number one, Sam has noticed a pattern between one of the diagonals of the generic rectangle and the expression for the area as a sum. A diagram of Sam's observations are shown below. So we've got four patterns here. What pattern do you notice between the expression for the area as a sum, so between the equations, and the designated diagonals? What do you notice? So if I take these two numbers, what similarity does it have to that one? Same thing here. If I take those two numbers, what similarity does it have to that one? All right, so I wrote down here the sum of the diagonal is the middle part of the area as a sum. So if we remember, sum means addition. So 2x plus 15x is going to equal 17x. A negative 5x and a negative 4x equals a negative 9x. A negative 2x and a positive 3x equals a positive 1x. And a negative 5x, positive 4x is going to give us a negative x. Right, so the sum, once again, the sum of these two numbers is going to equal that middle number right there. Question number two. While working on problem number one, Casey noticed a pattern between both diagonals of a generic rectangle. However, just before she shared her pattern with the rest of her team, she was called out of class. That drawing on her paper looked like the diagram below. Can you figure out what the two diagonals have in common? All right, so when we look at this, we're going to look and we're actually going to multiply them. So if I take 2x times 15x, and then I'm going to take the other sides of this and do 6x squared times 5, what do I get? 2 times 15 is 30, and x times x is x squared. And over here, we're going to do 6 times 5 is 30. And then I just take, since there's no x or x squared there, I'm just going to take the x squared. And we notice that those two things are equal. Perfect. So let's verify Casey's pattern works for all of these diagonals from problem number one. So I'm going to take 10x squared times 2. And I'm hoping that's going to equal negative 5x times a negative 4x. 10 times 2 is 20. And x squared times, well, nothing over there. Oops, sorry. So 10 times 2 is 20. And x squared is just going to come down as the x squared. Negative 5 times negative 4 is a positive 20. X times x is x squared. 20x squared equals 20x squared. That one checks out. Next one, 3x squared times negative 2. We're hoping is equal to negative 2x times 3x. 3 times negative 2 is negative 6. Then we've got the x squared. Negative 2 times 3 is negative 6. X times x is x squared. That checks out. And our very last one, x squared times negative 20. And we want that to equal negative 5x times 4x. Negative 20 times 1, because remember there's always that invisible 1, is going to be negative 20. Then we've got the x squared. Negative 5 times positive 4 is negative 20. And x times x is x squared. So that one also checks out. All right, so now we're going to use these patterns and use this information to help us fill in some blanks and kind of fill in the puzzles. So go ahead and go on to the next video.